Okay, so for this week, I think it's week 7 of the quarter already. We're going to be talking about pathways, and in lecture, you're going to see that we have growth pathways, radio label pathways, and accumulation pathways, which you're going to be seeing some of on your study questions and also on the midterm. Uh, and I thought it would be useful before we get into the different types of pathways to first go over some of the key points and key terms that keep coming up your in your lecture in lecture, and also for the problems that are going to be coming up when you're reading these pathway type problems. Okay, so the first term that I thought would be good to go over was this idea of strain. So a strain is an organism with or without a certain mutation. So you can look at the bottom over here, and what I drew, it's a simplified version, but it gets the point across. So you can think of it that strains are just different organisms that have different enzymes mutated inside of like one pathway or multiple pathways, but I'm just simplifying here. But you have different enzymes mutated inside of that strain. So for example, in strain A over here, what we saw or what we're seeing is that enzyme 2 is mutated in strain number 2, in strain A. And then strain B, that enzyme number 2 is working, but then it's enzyme number 3 that's not working. So what you do in these experiments, and the whole point of these experiments, is that you make different strains, okay, of the same organism, and what you're doing is you're basically mutating different enzymes on a specific pathway so that you can elucidate the order of intermediates in the pathway. So basically what the whole goal of this entire week's worksheet is, and the concepts we're learning this week, is we're going to be conducting different experiments where we mutate different enzymes in these strains, okay? And so each strain has a different mutation, and then by having multiple strains with different mutations, you can elucidate the order of the different intermediates, or like the different letters that I showed you over here, so that you can find the order of the pathway. So again, mutation, another key term. So that's indicated by the numbers, and that refers specifically to the enzymes. So we classically think that mutations, you only can mutate enzymes, not intermediates. So make sure you don't make that mistake, okay? And then intermediates themselves, they're indicated by letters. So what's happening here is that, for example, in strain A, just to summarize exactly what's going on. So strain A is an organism that has a certain mutation, and the certain mutation in this case is on enzyme 2, okay? And mutation, again, so we're mutating the number because that's the enzyme, not the intermediate. And strain B, on the other hand, is mutated at enzyme number 3. And we're going to talk a little. So the key idea here is that if you have a mutation in a strain, you can't get flow past that mutation. So this is a common misconception. A lot of students think that, oh, just when I'm mutating something in the strain, that means that all of the enzymes stop working. But that's not the case. When we say that we have a strain, we're just mutating one of those enzymes, or unless specified that there's more enzymes that are being mutated. But in general, we're mutating one of the enzymes, okay? And all of the other enzymes we're going to assume are still working. So for example, if I'm looking just at strain A, right? I'm looking at strain A, and I mutate, and in strain A, enzyme number 2 is mutated, okay? So if, let's just say I added back C, so somehow I fed C to the organism so the organism can now eat C, well, even though enzyme number 2 is not working and the strain can't make C on its own because enzyme 2 can't convert B to C, if I provide the strain intermediate C on its own, then the intermediate can then, because its other enzymes are still working, it can still produce the last intermediate, or like the end product D, okay? So the idea here is that if you have a mutation, you can't get flow past this mutation. So you could think of it, this is kind of like a roadblock. This is going to block everything before it from going through. But if I add back intermediates after the mutation, this enzyme continues to work, and same with enzyme number 1. So if I added A, I can still convert some of it to B, okay? But it's just that enzyme 2, because that's mutated, I'm not going to get flow past it. So that's the basic idea, and now we're going to be conducting different experiments with different types of pathways. So growth, radio label, and accumulation all have a little bit slightly different logic behind it, but the basic principles are the same. So let's just try it out over here. Okay, so I'm gonna continue leaving this here. And now what we're gonna do is we're gonna go to say there's gonna be 3 different types of pathways, okay? So there are gonna be 3 different types of pathways that we're gonna be learning about in this class. The first one is accumulation. So accumulation of intermediates before mutation, intermediates after cannot be made. So just to explain what this is showing, so let's go back to strain A. So if we're looking at strain A, and we're gonna end up mutating enzyme number 2, okay? So that means that if I'm providing it A, what's gonna happen is that A can be converted to B, so you're gonna get accumulation of those intermediates, but because C and D come after the mutation, you are not going to be making these intermediates after that mutation, so you're not gonna see an accumulation of those intermediates, okay? Another key thing that I wanted to add for accumulation is there's going to be different problems talking about irreversible steps versus not, where you should consider irreversible steps and where you shouldn't consider irreversible steps. So make sure you read the problem, and that'll change the way that you're going to answer the question for accumulation problems. Okay. Then the next thing we're going to go to is radio label. So this is I like to think of these as using very similar logic, accumulation and radio label, and I'll explain why in a second. So it says label cannot be passed to intermediate after the mutation, i.e. intermediates after mutation will not contain isotope label. So in this experiment, the same thing's happening. So we're gonna be radio labeling. Let's say we put a radio label marker at the bottom of A, okay? That radio label is not gonna be passed to B. Because enzyme 2 is not working, okay? What's gonna happen is we're not gonna pass the radio label to C and D, so we're not gonna see radio label in C or D. Now, if we look at strain B, for example, if I radio label A, it's going to be passed to B, it's going to be passed to C. But because enzyme number 3 is mutated, I'm not going to pass the radio label to the end product D. Okay, so accumulation and radio label are kind of the same because you're going to accumulate or you're going to get radio label for the stuff before your mutation, but you're not going to see accumulation or radio label after your mutation. Okay. There's a slight difference, and it'll come when you go to lecture and stuff like that, but I just wanted to give you guys the main idea from these pathways, okay? Then we also have growth pathways. So growth pathway, it uses a slightly different logic, and it says if end product is essential, okay? So this is a key word, essential. The organism requires that nutrients for growth. And then it says can add back intermediate after mutation to bypass. So let's see what we mean over here. So whenever you're ever given a growth pathway, it's going to always tell you what is essential for that pathway. So for example, let's just, let me tell you guys, let's just say that in strain A, we're going to say that D, this thing over here, so D, or I'm just maybe going to just draw it out. We're going to say that D is essential, okay? And what essential means is that this strain A needs to produce D, otherwise the strain is going to die. So now if D is essential, organism needs to make D or be given D to survive, okay? So if it's not going to make D on its own, then we need to provide a D so that the organism could survive. Of course, there's going to be other problems where you could have multiple essential nutrients, and that means that you need to produce all of those essential nutrients, but I'm just going to do it for an example of one, okay? So the idea here is that if D is essential, organism needs to make D or be given D to survive. So let's just say that in this strain, again, what we're doing is mutating enzyme number 2. Well, the strain is going to then be able to convert, so it can convert A to B, so we're going to be able to make A and B. So we're going to see an amount of A and B. And what's going to happen is, can we get to C and D? No. So now the point of a growth pathway is says, we can add back an intermediate after the mutation to bypass the mutation. So for example, if we know that D is essential, what do you think we can add to strain A so that it can live? Well, you're going to say, obviously, you can add back C, right? I mean, you can add back D because D itself is essential. So if the strain is not making D itself, but we add back D in our experiment, the strain is going to live. How about if I added back C? Well, if I add back C, C can be converted to D, which will help make our essential end product, so that's good too. What if I add back B? Well, if I'm adding back B, in this case, because B is before the mutation, B can't be converted to C, which is then converted to D. So because B can't be converted to C, I'm never going to make my essential end product, and that's why the strain is going to die if I only give it back B. Now, let's go to, for example, let's compare strain A and strain B, okay? And let's add back C. So for a growth pathway, let's say again, we're saying that D is essential in both of these. And now let's add back C to both of these. So this is where the key difference comes because every strain has a different mutation. So if I add back C right now, so if I add back C to strain A, we just said that strain A, because enzyme 3 works, C can be converted to D and I produce my essential end product, so D will help the strain A live. But what if I add C to strain B? Well, if I'm adding C to strain B, because enzyme number 3 is not working, right? C can't be converted to D, D will not be produced, and strain B will die. So that's why these experiments will give you different data, and you can figure out the order of the different intermediates in the pathway based on which strain lives and which strain dies. Because now you know, based on these two experiments, that enzyme 3 is between C and D. Because strain A lived, but strain B did not live when he mutated enzyme number 3. So hopefully these key ideas or these different types of pathways, the basic concepts of them make sense to you guys. And I'm going to make one more video like with the table summarizing all the stuff I just said in the next video.